Hello and welcome to this session. This lesson will be about explaining when to use an absolute value as you simplify square roots, even roots, and when not to use an absolute value. So let's talk about the principal or positive roots. The principal root is the positive root. Say when you take the square root of 25, your answer would be a 5, and that's positive because this radical symbol means the positive square root. But if you're asking about square roots to the number 25 without using this symbol, what are the square roots of 25? You're going to say it could be 5 or it could be negative 5. Why? Because 5 squared equals 25 and negative 5 squared equals 25. So if you square 5 and you square negative 5, both of them will give you 25. But whenever we use the square root symbol like that, this includes in the meaning that this is the positive root. So we're asking that you get only the positive answer. If we want the negative square root of 25, then that's how we write it. So you find the square root of 25, which is 5, and then you take its opposite, or the negative. So that's when we use the radical for a square root, becomes more challenging because we're dealing with variables. If we're dealing with numbers, we know what to get for an answer. Again, if we have the square root of 36, we're just going to say the positive root is what we're looking for is 6. And we don't have to worry about having the answer being negative. The answer must be positive for taking square roots of positive numbers. So here, if we take the variable x, and we don't know if x is positive or negative or 0, we don't know the value of x, it's a variable, then we're going to be careful that our answer is going to be positive. And just in case, so think about x being the number negative 3. If x was negative 3, then the square root of negative 3 quantity squared is the same as the square root of 9. So we're okay with that. We have a positive number under the radical. And you know that the square root of 9 is a 3. So we're fine with that. But if you replace x by negative 3 and you say my answer is x, then you're going to get negative 3 for the answer. And that does not make it a true statement. So you cannot simply say the answer is this number that raised to the power 2 regardless if it's negative or positive, because we have this statement is correct because those are equal, and that gives you a positive 3. So here, if you say x, chances are the x could be something like negative 3, could be a negative number. And so we cannot get a negative number for an answer to a square root or a principal root because that includes in its meaning a positive root. So to take care of this, not getting something like that, you're going to say it's the square root of, it's the absolute value of negative 3. So this would make it a true statement. The absolute value of negative 3 is 3. So that would be an appropriate answer. Of course, you have to read the instructions because if they say assume the variable is any real number, so you're thinking any real number is any number on the number line, and that could be negative. Then that means you have to take care of your answer to keep it positive. Notice that x could be negative, but x squared is positive. So we're okay with that because having a negative number under the square root is not a real number. Now let's look at the square root of x cubed. The square root of, if you look at x cubed, do you think x could be negative? Can we take a negative number and cube it to get positive? So think, if x was negative when you cube it, you got a negative number when you raise to an odd power. And so if that had a negative number, then we can simplify it. So we're going to make the assumption that x is positive here. And so I'm going to say my answer would be, if I break it down to x squared, square root of x squared times x using the product rule, then that's going to give me square root of x squared is x times radical x. And you know what? I could put an absolute value here, but I don't really need to, because my argument here in the beginning that x has to be positive without even being told, because it was negative, I cannot do it. It wouldn't be a real number. So I'm okay with leaving this x without an absolute value here, because I know x cannot be negative. Now, if I look at the square root of x to the 4, is it possible that x could be negative and the radicand x to the 4 positive? Yes, it is, because if x is negative and you multiply it by itself 4 times, an even number of times, it's going to be positive. So I have to worry about x being negative. So I'm going to say, well, to simplify the square root of x to the 4, I know it's x squared, because when I square x squared, I get x to the 4. When I square x squared, I get x to the 4. But do I really need to worry about, even though there's a chance that this x can be negative here, but do I have to worry about about the answer being negative? Notice that if x was negative when you square it, it's going to be positive. And if it's positive, when you square it, it's going to be positive. So there's no need to put absolute value here. Now let's look at the next example, square root of x to the 5. Well, square root of x to the 5, when you simplify it, you're going to get what? X squared times the square root of x, right? And again, x to the 5, there's no way that x could be negative, and we could simplify it. So I'm just going to say I'm not going to worry about absolute value anyway. And even if I do worry, I know x is squared. I know my answer is positive. So that would be, I put this answer, and I'm confident that my answer is positive. Now let's look at the square root of x to the 6. Well, square root of x to the 6, I know it's x cubed. Why? Because when you take x cubed and square it, you get x to the 6. And so ask yourself, can x be negative here? And then the radicand positive. Yes, if x is negative, when you raise it to an even power, this radicand is positive. So we can simplify this radicand. Now, x could be positive or negative here. So our answer must be positive. How can we make x cubed positive? Now here we need to put an absolute value around the x cubed. So for every problem you simplify, if the instructions say assume that the variable is any real number, you've got to assume it could be negative. And then you've got to investigate the case. If it was negative here, would my radicand be negative? And if so, then we're not going to assume that it can be negative, otherwise we can't simplify it. But if x is negative and then the power on it is even, that means this could be positive, but yes, yet the answer, like here, this could be positive, so we're okay, we can simplify that, but we have to be careful the answer is positive. But when that x, if it's negative raised to an odd power, that's going to give you a negative, so there you must put the absolute value. So hope you understand this principle. So let's take an example where you would simplify and use the absolute value. Let's say, assume all variables are real numbers. So they could be positive, negative, or 0. So we're going to take 9, x to the power 6, y to the power 8. And we need to simplify it. Well, the square root of 9 is a 3. So I know it's positive. There's no need to put an absolute value around it. Think x and y, they both could be negative. But when you raise them to an even power, then my radicand is positive. So I'm OK with that. So, and then x to the power 6, when you its square root is x cubed. But because this x can be negative, then x cubed raising to an odd power could be negative, so I'm just going to go ahead and put the absolute values around x cubed. Y to the power 8, it's going to give you y to the power 4, because when I square y to the 4, I get y to the 8. But I'm not going to put absolute values around the y to the 4, because I know that number, if it was negative raised to an even power, it's going to be positive. So hope that clarifies some confusions about the use of absolute value for simplifying radicals or not. See you next time.